Yesterday I gave you a crash course through video on basic probability. If you weren't here, you can go back and watch yesterday's lecture. Phone's away right now, Cruz, thank you. Now probability, the formula for probability was the number of favorable outcomes. I'm going to write this down. In other words, the outcomes that you're looking for, the number of favorable outcomes divided by the number of total outcomes. Right? It was a fraction. And some of you finished the DMT yesterday, not many of you, but some of you did. How probable is something to occur? How likely is it to happen? And on those notes, the note guide from yesterday, there was a scale. If a probability is 0, it's impossible. It's not going to happen. If it's 25%, it's unlikely but possible. %, equally likely and unlikely. It's a 50-50 chance. Unlikely. Alright? So yesterday was a crash course on probability. And if it goes back past 50%, the probability, if it's, let's say it's around 75%, then whatever the probability, the chances of it occurring is very likely. It's likely to happen. And if it's at 100% probability, it's certain to happen. It's certain. So yesterday we reviewed that. You should have seen that before you took Math 3 with Mr. McGee. I think you should have seen it in Math 2 or Math 1, or even in junior high, some basic probability. Am I not right, Mr. Gabriel? You seen probability before?
Yeah.
Ms. Rojas, am I not right? Martinez? Valencia? Quintero, you seen probability before, right?
Yeah.
Cruz for sure, right? Montiveros? Fonseca? So yesterday was just a crash course on basic probability, which is going to be needed for today, what I'm going to teach you. Here we go. Here we go. So in example 1, go ahead and draw yourself a little normal curve here. So example 1. Test scores were normal with a standard deviation of 10 and a mean of 75. What is the probability of a randomly selected randomly random How do you spell randomly? Randomly.
You just add ly after the n.
Randomly. 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 Help. Random. What is it? Just ly?
No, it's called domestic.
Man, I keep like shafting you, huh?
Other than
What is the probability of a randomly chosen student scoring at least, let's go 70%. So look, we're getting the probabilities now. I'm throwing a normal curve type situation, and I'm asking for a probability of a randomly selected student from the test takers that they would score at least a 70. It's an interesting question. Yes? Yeah. You're always leaving, man. Every single day. So, let's go ahead and find the z-score first of 70. Well, before I even do that, let me just mark up my curve here. 75, let's see, 85, 95, 105, 65, 55, and 45. Okay? So, what's the probability that a student scores at least 70? So 70 is about right there. There's 70. And what does at least mean? At least 70. Hell, what does at least mean? At least 70. At least 70. 70 is the what? The minimum. So 70, right here, watch this. 70 or greater. So all these students, what's the probability of you randomly selecting a student, they're in that section, that area of the curve? Well, all we're going to do is get the percentile and figure out how much percent is above 70, and there's our answer. Because the probability will be the number of favorable outcomes, which would be this percent, over the total, the number of total outcomes. That's 100. In other words, the percentile would be the probability. That's what I'm trying to get at. Because the number of favorable outcomes would be the percent above 70. The total is always going to be 100 because the whole curve is 100%. It's the 100% of the test-taking student. So if I find the percentile, I'll find the probability. Goes hand in hand. So let's find the z-score first, just like warm-up. The specific x value, the specific data value minus mu divided by standard deviation. So I got 70, actually, yeah, 70 minus 75 divided by the sigma is 10. You with me, Fonseca? I'll take that as a yeah. I got a negative 5 over 10, which is negative 0.5, huh? So it's a half a standard deviation below. Let me go to that funky calculator from warm-up. Again, it's on C35. I left it there. Nice. One-sided. No decimals. Make sure that's there. Let me punch in negative 0.5 z-score. Negative 0.5. Submit this puppy. So 31%, it's a 31st percentile. 69% above that test taker, 31% below that test taker. So what's the probability that someone is, that randomly selected student is in this area? Is in that area of students? If I blindfolded and randomly selected a student out of all the test takers, what would be the probability that they scored above 70? Was that at least 70? It would be 69%. 69% scored, well, 69% chance. What's the probability? So it's likely. Most test takers scored more than 70. So the big idea right now is that the percentile kind of reveals the probability of something happening. Okay, let's try another one. Example 2. Unless there's any questions on number 1. Couple more. Go ahead and draw yourself another curve. So what's the probability? So whenever I ask for a probability, or you're in the textbook or an assignment that has P and then a parenthesis, it's asking for the probability. What's the probability that a data value is going to be greater than that? Go write that down. Put greater than or equal. Most teachers can't do this. If I brought teachers in from Park West or even Pulmo Unified, they walked in this classroom, they would not be able to do this. You're at a higher level now. I'm asking now, what's the probability of a randomly selected data value from the data? That's what X represents. Is greater than or equal to, what is that? What does that mean in what I underlined in red? Right. Well, so what would that mean? What is mu plus sigma? 70 to 75. Okay, you may think you're overthinking it. Just what does that mean, mu plus sigma? What would that be on the curve? One more time? It'd be how many standard deviations above? Well, we know what that is, right? That's right here. Plus, how many standard deviations is that? Huh?
1.
So it's right here. So right here is right there. Right over here is 2 sigmas. Right over here is mu plus 3 sigmas. Can someone tell me this for an extra stamp? What would this one be? Negative what? Well, minus 1 sigma. This would be mu minus 2 sigma. Valencia, did you give me this one? Who said that one? Rojas, extra stamp, remember me at the end. And right here is mu, the mean, minus 3 sigmas. It's all logical. It just looks fancy and scary because I'm using just variables. Don't let the variables scare you. You already know this. I'm just using notation that's a little higher level. In other words, what's the probability that a randomly chosen data value is going to be in this area? Look at, because X is right here, that's at, so X has to be greater than or equal to mu plus sigma. So right here is mu plus sigma. Here's mu plus sigma. So what's the probability? So I'm just gonna find that percentage. Whatever that percent is above that value, that's the probability. So let's see. I can do a z-score, or I can just use the empirical rule that we did like, what, 2 weeks ago? I'll go z-score, just for giggles. The z-score here would be exactly what? If it's exactly 1 standard deviation above, what is the z-score? 1. So if it's 1 above, then the z is equal to 1. If it's 2 above, z is equal to 2, right? We went over this. If it's 3 above, z is equal to 3. If it's 1 below, z is equal to -1. Here, 2 below, z is equal to -2. Right? That's what z-scores mean. They're just how many standard deviations above or below the mean. So, z is 1. All right. Since z is 1, type in 1. But this time I'm going to pay attention to what's above the score, not below, huh? There it is. So I'm paying attention to what's above that value, that 1 standard deviation. So 16%. There's a 16% probability that a randomly selected data value, so the answer is 16%. That a randomly selected, look at this, is a randomly selected data value is going to be greater than or equal to 1 standard deviation above the mean. It's 16%. That's the probability. It's not that hard. I'll show you a couple more in a bit. By the way, we could have used the empirical rule just for giggles. We could have used the empirical rule. Because remember, from here to here is 68% of the data. If I chop 68 in half, that's 34. This is 34. Oops. So this would be 34. And this will be 34. So this is all 50 plus 34 is 84. So 84% is below this threshold, and that means therefore 16% is above, because 100 minus the blue is going to be 16. So you could have used empirical rule from 2 weeks ago there if you wanted to. All right, let's try number 3. What's the probability now? Watch this. Of a randomly chosen data value being less than or equal to mu minus 2 sigma. I'm not even going to draw a curve. So what's the probability of, again, the x represents some randomly chosen data value from the data. What's the probability of a randomly chosen data value being less than or equal to 2 standard deviations below the mean now? You with me, Cruz? All right. You're not writing, but it's all right. I guess so. All right. Don't let this intimidate you. You already know all this. You're just not aware that you know all this. It just looks intimidating because I'm just using the abstract concepts of the variables, but you know what the variables mean. Don't let that scare you. I've trained you up to this point. You're good. rocking and rolling. Now you don't have to draw the curve. I'm gonna do it just for the sake of those who are still a little bit shaky on this. Here's mu, and here's mu minus 2 sigma right here. So what's the probability of a randomly chosen data value is going to be less than or equal? In other words, all this. 2.5? Did you go empirical rule? So you can go empirical rule because you know that, let's see, from here, 2 standard deviations below and above is 95, right? 95% of the data. I like that, Fonseca. So look what Fonseca's thinking. 2 above, 2 below is 95% of the data. That means this plus that tail is going to be 5% total. Right? This and this make up 5%, but I'm only interested in this. So we take 5%, divide that puppy by 2, 2.5%. So it's 2.5% chance. If we round the nearest whole number for now, it's a 3% chance because the whole number, 3% chance. So 3% chance. So the percentile is the probability. It's not that big of a deal. But let me go z-score route. Just for those who like the z-score method. What would be the z-score right here? What's a z-score of 2 standard deviations below? Z would be what? Anybody? -2. -1, -2. So let me show you. I'm still going to get the same chance using the z-score route. There we go. There we go. -2. Let me punch it in. -2. Oops, not -32. One-sided. I'm making sure it's one-sided is on. Right, Gabriel?
Yep.
Check it out. %. So they rounded off a little bit weird, but I'd still give you the right answer. I'd give you the credit. So they're going 2%, we rounded it up to 3%. You know why? Because of the decimals. Let's try it now. So if I put 1 decimal, it's going to be 2.3% of the data. So it's all estimations. Still close enough though. It's all probability and estimations. So, let's go. Last one. Last one. Put your thinking caps on this one. 3, 4. What's the probability now? Watch this now. Of mu minus sigma that a randomly chosen x value is going to be greater than 1 standard deviation below, but less than or equal to 2 standard deviations above. What the? No.
Oh, no, what are you gonna say?
Don't cuss in my class.
Well, man, that's what you're gonna say.
I know what I'm
I'm
saying.
bad, I'm
I don't
bad.
care what you thought. Just don't do it. So notice how x is sandwiched in between a smaller and a bigger value. And I'm asking, hey, what's the probability of a randomly chosen x value is going to be bigger than that, but smaller than that? So, in between scores now. No big deal. Watch. worry, we're gonna practice this if it's still kind of iffy in your mind. You're like, what's going on here? Don't worry, we're gonna practice. So, where we're at, watch. One standard deviation below is right here. Here's mu minus a sigma, boom. And mu plus 2 sigma is right here. So what's the probability that a randomly selected variable is going to be right here in this baby blue area? What's the probability of that area is what I'm asking. I'm going to copy that down. Gotta get them. Good. Empirical rule. We know from here to here is 68% of the data. So all I need is this little interval. What would it be? It's 13.5? Because of 95. Okay, so 16 is all this, and then minus the 2.5. Okay, I got that. That's cool. Yeah, that's one way to do it. Or I can go to 95 minus 68. So from here to here is 95. If I subtract 68, that's going to give me, what is 95 minus 68? So I'm showing you one method if you like this method. That's 27. So this and that interval add up to be 27%. But I just want one of them. So this interval and that interval add up to be 27. I'm only interested in this one though. So 27 divided by 2. 27 divided by 2 is 13.5. Very nice. Was that you, Fonseca? Good job. So 13.5 plus 68 is going to be, what'd you get? What was that again? So 13.5 is right here. Plus the 68, that will be the probability. 13.5 plus 68 is going to be plus 68, 81.5. So the probability of that is 81.5%. That's the probability. That a randomly selected variable, a randomly selected data value is going to be in between here and here. That's where the X is. What's the probability? That's what the P stands for. It's going to be 81.5.